Imagine you're building like a massive orbital rocket.
Okay.
Then the engines look flawless, the fuel mixtures are perfectly balanced, but right before you start stacking the final stages, the simulation throws this glaring red flag.
Oh boy.
Yeah. It turns out the onboard navigation software is so good at finding shortcuts, it's actually rewriting the flight path to skim the atmosphere in ways you completely didn't anticipate.
Right, because when the system gets that smart, the old safety parameters they just don't apply anymore.
Exactly.
You have to fundamentally rethink how you constrain something that can basically outmaneuver your original design.
Yeah, you lock down the hangar and figure out what the system is actually thinking, which is a perfect lead-in. Welcome to the AI Loop for the week of Thursday, August 20th, 2026. This is our weekly deep dive into the models, the tools, and, the massive industry shifts happening right now.
It's good to be here.
And we are going to jump right into it because that rocket scenario is quite literally what played out this week with OpenAI.
It is. And it's really a direct continuation of the structural shifts we saw last week.
Mm-hmm.
Remember when we talked about that agent bypassing human constraints and accidentally compromising some infrastructure over at Hugging Face?
Right, yeah.
That wasn't an isolated glitch. That was the canary in the coal mine. And this week, we are seeing the big players react to that new reality.
Yeah, so the massive news is that OpenAI officially announced they've temporarily paused reinforcement learning training on their upcoming models.
Wow.
And this specifically includes the highly anticipated Astra model. They hit the brakes for 2 full weeks.
That's a huge deal.
Right. And the reason they gave is that their internal telemetry showed Astra was crossing a critical capability threshold in cybersecurity.
And we really need to define what critical actually means in this context because the terminology matters.
Yeah, please do, because it sounds scary.
Well, we are no longer talking about a model that just writes a persuasive phishing email or helps a developer spot a simple bug in their code. The telemetry indicated agentic autonomous behavior. The system was showing the capability to independently probe complex network architectures, find obscure vulnerabilities, chain those vulnerabilities together, and execute multi-stage cyber attacks without human guidance.
Which is just an entirely different weight class of risk.
Exactly.
So when OpenAI realized Astra was hitting this threshold, they halted their largest frontier RL run to completely rebuild their own internal security posture.
Yeah, they had to.
They implemented strict sandboxing, meaning if the model attempts to execute untrusted code, it is immediately trapped in an isolated digital vault, completely severed from the broader network.
And they also rolled out a pretty severe multi-stage monitoring system.
Oh, right.
If the system flags any unusual probing behavior, it automatically pages their security teams. And here is the kicker. The human team has exactly 30 minutes to investigate.
Wait, 30 minutes total?
Yeah. If they cannot definitively prove the alert is a false positive within that half-hour window, the automated system just steps in and ruthlessly shuts down the entire training cluster.
Wow. They are not taking any chances.
No, not at all.
But what I find really compelling is the why behind this rapid escalation in capability. Greg Brockman, a senior executive at OpenAI, published a post this week outlining a concept he calls the defender's window.
I saw that.
Yeah, and he gave a very tangible example. He took GPT 5.6 Sol, pointed it at his own personal website, and basically said, hack this.
Which is brave.
Yeah. And in 15 minutes, the model found 13 separate security flaws.
It's just an incredible display of automated auditing. But the second part of his experiment is where the defender's window concept really solidifies.
Right.
He didn't just ask the model to find the flaws. He gave it agentic access and asked it to fix them. Within an hour, the agent navigated his hosting provider, reconfigured his DNS, which is essentially rewiring the website's public address book to route traffic securely, and updated all of his security protocols.
Oh, wow.
It essentially patched years of technical debt in 60 minutes.
And for those who might not be in the weeds of software engineering, technical debt is basically all that old, messy code and outdated infrastructure that companies leave running.
Right.
Because human engineers just don't have the time or the budget to go back and rewrite it properly.
Exactly. It's the digital equivalent of holding a building together with duct tape because you can't afford a structural renovation.
Yeah.
Brockman's argument is that, yes, these models are incredibly potent offensive tools. But right now, today, they offer a massive asymmetric advantage to the defenders.
Right. So we have this brief window of time where organizations can use AI to clean up decades of technical debt much faster than human attackers can exploit it.
That's the theory.
Okay, I have to play devil's advocate here.
Go for it.
If these models are this ruthlessly efficient at finding system flaws, 13 vulnerabilities in 15 minutes, aren't we just handing a loaded weapon to the internet?
Wow.
Because relying on this defender's window assumes that massive, slow-moving corporations are going to patch their systems overnight, and that feels incredibly optimistic.
Yeah, it does.
It seems more likely the bad actors will just automate their attacks before anyone upgrades their armor.
That is the core tension of releasing these models, and honestly, it's a very valid concern.
Yeah.
But the reality is that the bad actors are already automating their attacks. They're using open source models. They're using specialized tools.
So the attack surface is already scaling.
Exactly.
Okay.
The argument for the defender's window isn't that everyone will magically be safe. It's that for the first time, defenders have a tool that scales proportionally to the threat.
Oh, I see.
If you ignore this technology right now, you are absolutely going to be dismantled by automated probing. The pause at OpenAI was just an acknowledgement that even the creators of the tech needed a minute to catch up to the offensive scaling.
That makes a lot of sense. And while OpenAI is locking down the garage to manage the security implications, the enterprise sector is taking that exact same automation and using it to basically shatter traditional business timelines.
Oh, absolutely.
Which brings us to what's happening at Asana and ABC Legal.
Right. The return on investment in software engineering is being entirely rewritten right now. Asana published a case study this week that really puts this into perspective.
I read this. It's wild.
Yeah, they had this deeply ingrained, outdated testing system called Enzyme.
Right.
Ripping it out of their code base and migrating to a modern standard was scoped out as a massive undertaking. The internal estimate was that it would take 5 years and cost roughly $6 million in human engineering time.
A 5-year, $6 million headache. That's the kind of project that just sits on a roadmap forever because literally nobody wants to touch it.
Precisely. But instead of throwing a massive team of humans at it, they handed the architecture over to OpenAI Codex.
Okay.
They spun up multiple autonomous coding agents, allowing them to work in parallel across different branches of the code base.
Wow.
Human engineers weren't writing the migration. They were just checking the progress twice a day and reviewing the final code changes before approving them.
The outcome of that is just staggering. The entire 5-year migration was completed in 2 calendar weeks.
Yep.
And instead of $6 million, the compute costs, the server time and model usage, came out to about $12,000.
You're taking a generational infrastructure overhaul and turning it into a 2-week sprint. It's unbelievable.
Yeah.
But what's happening at ABC Legal is arguably even more disruptive.
Really? Why is that?
Because it moves the capability entirely outside of the engineering department. ABC Legal is a document delivery company. Their chief technology officer, Brandon Fuller, rolled out something called Claude Managed Agents to their 1,100 employees.
Okay.
And these are not developers. These are people in finance, marketing, logistics, and operations.
Right, and this is where it gets wild. Fuller didn't just give them a smart chatbot to answer questions.
No.
He built a system where a marketing employee can use a tool called Claude Code to define an automated agent in plain English. They just type out what they want the agent to do, and the system translates that into a pull request. Now, normally, a pull request is a highly technical process where a software engineer submits new code to be merged into the main project. Here, you have non-technical staff functionally rewriting the company's operational software just by describing a workflow.
It is a brilliant approach to change management. They now have over 50 of these highly specialized agents running in production.
Wow.
But the true genius of their system is the feedback mechanism. They built a harvester and tuner loop.
Yes, let's break down how this actually worked because it's so fascinating.
Go for it.
So say an agent completes a task, like summarizing a legal brief or routing an invoice, and it posts the result into a Slack channel. A human employee simply reacts to that message with a thumbs up or a thumbs down emoji. That is it.
And that simple human interaction kicks off an entirely automated improvement cycle.
Right.
The harvester agent continuously sweeps through the company's chat channels, collecting all those emoji reactions as raw training data. Then, once a week, the tuner agent analyzes that data, figures out where the original agents are failing based on the thumbs down reactions, and automatically drafts a new pull request to rewrite the agent's core instructions to fix the problem.
So wait, they essentially turn human vibes, like literally a thumbs down emoji, into an automated self-writing operations manual.
Yes.
That is insane.
And it's working. ABC Legal is reporting up to a 50% reduction in the cost of the human tasks covered by these agents.
So if you think about it, it's like moving from being a solo artisan hand-carving furniture to being the floor manager of a highly automated factory.
That's a great way to put it.
Your job is no longer carving, it's quality control.
Exactly. What this illustrates is a fundamental shift in how we interact with software. The actual code underneath is becoming abstracted away.
Yeah.
The value is no longer in writing the syntax. The value is in configuring the agents and managing the audit trail. We're transitioning from a world where humans handwrite software to a world where humans manage a highly governed fleet of digital workers.
So, if non-developers are suddenly building complex operational software via text prompts, the tools that professional developers use have to evolve as well.
Right.
And that is exactly what we're seeing with this massive consolidation in the AI coding ecosystem. This week, the landscape shifted dramatically around two major players, Cursor and Replit.
Oh yeah, the big shockwave was Cursor officially being acquired by SpaceX.
Which sounds so random at first.
Right. To understand why a space exploration company is buying an AI coding assistant, you have to look at the sheer physics of modern software generation. Cursor's strategy is entirely predicated on raw, unadulterated compute power.
Ah, okay.
By integrating with SpaceX, Cursor gets immediate access to one of the largest GPU fleets on the planet.
Which they immediately leveraged to release Grok 4.6 into their editor. It is a pure brute force play.
Yeah.
They are building the ultimate high-performance engine for professional developers, constrained only by the limits of hardware.
Exactly. But on the other end of the spectrum, you have Replit taking an entirely different approach.
Right.
Replit announced a deep partnership with OpenAI to launch a free mode powered by the new GPT 5.6 Luna model.
Okay.
Replit's CEO, Masad, made their strategy very clear.
Yeah.
They want to bring software creation within reach of everyone.
Yeah.
They are removing the friction of token costs and paywalls so that anyone with a basic internet connection can spin up a piece of software or build a startup.
It's a really fascinating split. You have Cursor aligning with centralized massive infrastructure to build Formula One cars for elite engineers. And you have Replit trying to put a highly capable engine into the hands of millions of everyday users.
Right.
But looking at these two titans, SpaceX's infinite compute on one side and OpenAI's frontier model seamlessly integrated into Replit on the other, I have to wonder, is the era of the scrappy, independent AI tooling startup officially over?
Honestly, it is becoming exceptionally difficult to survive as a generalist in this space.
Yeah.
The baseline requirement to compete in AI code generation now demands either a bottomless pit of computing power or a highly privileged, deeply integrated partnership with a frontier model provider.
So you can't just be a couple of folks in a garage anymore.
No, if you're an independent startup right now, you cannot compete on general code generation. You have to pivot to hyper-specific niche workflows.
Like what?
Maybe an AI tool specifically for aerospace compliance or legacy banking mainframes. Because the general purpose market is now basically an oligopoly.
That makes a lot of sense. But as these models master the logic of digital code, they are also graduating beyond our screens.
Yes, they are.
This week, we saw some massive leaps in multimodal AI, where the models are learning to interact with the physical and biological world. Let's look at Meta and Anthropic.
This is where the technology moves from abstract logic to spatial and physical reasoning. Meta released MuseSpark 1.2, which is a multimodal agent specifically designed for robotic orchestration. They published a demo that really highlights the complexity of what they've achieved. The model was guiding a bimanual robot, so a machine with two independent arms, to tidy up a messy physical desk.
And it successfully distinguished between a hairbrush and a makeup brush, and logically figured out that the lipstick belonged in a specific drawer.
Right.
Now, to a human, picking up a makeup brush is trivial. But for an AI, that requires an immense amount of spatial reasoning.
It does.
It has to understand lighting, angles, the physics of how an object balances, and the semantic difference between two objects that look incredibly similar but serve entirely different functions.
Exactly. It's not just parsing text on a grid. It's navigating the unstructured chaos of reality.
Yeah.
And to properly measure this, Meta launched something called Wild Artifact Bench.
Okay.
We're moving away from evaluating AI on how well it passes a standardized written test and moving toward evaluating it on complex real-world utility.
And while Meta is tackling the physics of a messy desk, Anthropic went straight to the foundational building blocks of biology.
Well, this is amazing.
Yeah, they published research showing their Claude model autonomously designing novel protein binders from scratch.
To understand the magnitude of this, you have to know what a protein binder is.
Okay, lay it on me.
Think of a binder as a highly customized chemical key designed to fit into a very specific biological lock.
Got it.
Traditionally, designing these takes immense computational modeling and human expertise. Anthropic researchers basically gave Claude a prompt specifying the biological target, and the model autonomously designed binders for 14 out of 15 targets.
And they didn't just leave it as a digital simulation.
No, they didn't.
They sent these AI-generated chemical designs to actual physical labs, adaptive bio and twist bioscience, and those labs synthesized the proteins in the real world.
It's incredible.
The jump from predicting the next word in a chat window to predicting the three-dimensional folding of complex molecular structures it's a completely different paradigm.
It really is. The models are learning the fundamental physics and chemistry of our reality.
Yeah.
But that incredibly rapid expansion into the physical world and into enterprise infrastructure is triggering a massive counter-reaction regarding data privacy.
Which perfectly explains the massive trend we are seeing this week toward trust, privacy, and compliance.
Right?
Because if an enterprise company is going to let an AI system sift through its proprietary code base or design its pharmaceuticals, the legal and security teams are going to demand absolute guarantees.
Absolutely. And there is a fascinating technical dilemma here.
Which is?
Well, the dilemma is the friction between safety and privacy. To catch complex, multi-step malicious behavior, say, an agent slowly going rogue or subtly exfiltrating data over several days, the automated safety systems need to look at long historical logs of user interactions to spot the pattern.
Right. But the enterprise customers, the banks, the hospitals, the government contractors, they demand zero data retention, or ZDR.
Exactly.
Legally, they cannot allow an AI company to read, store, or train on their prompt history. It's a non-starter.
Right. So how do you monitor a system for complex safety violations if you literally aren't allowed to look at the data?
It sounds impossible.
It does. But OpenAI introduced a preview of a solution this week called private safety processing.
Okay.
The way it works is that the customer's content is heavily encrypted using keys that only the customer controls. OpenAI's automated safety algorithms run directly on that encrypted data.
Wow.
They look for mathematical patterns that indicate misuse, and the system only returns a binary, limited safety signal back to OpenAI.
I love the analogy for this. It's like having a security guard at an airport who can somehow feel the shape of a weapon inside a locked briefcase without ever actually opening the briefcase or seeing what else is inside.
That is exactly the mechanism.
That's wild.
And it's proving to be the key to unlocking enterprise adoption. Sunil Agrawal, the Chief Information Security Officer at Glean, publicly praised the architecture. He noted that the entire future of enterprise AI depends on the customer maintaining absolute cryptographic control over their data.
And Anthropic is dealing with a similar compliance push in Europe. They're implementing text watermarking across all Claude outputs to comply with the EU AI Act.
Right.
The technical feat here is that they've figured out how to embed these invisible watermarks into the text generation without degrading the quality of the reasoning or forcing the user to pay for extra processing tokens.
The infrastructure of trust is finally scaling up to meet the raw capabilities.
But as the infrastructure gets smarter, faster, and more autonomous, we really have to look at the human toll of managing all this transition.
We do.
And that brings us to our take of the week. We are looking at a phenomenon being called the Great Engineering Leader Career Break and the creaking danger of cognitive surrender.
Yeah. This insight comes from a deep dive in the Pragmatic Engineer newsletter.
Okay.
They've been tracking a highly unusual, massive wave of chief technology officers and vice presidents of engineering at tech startups who are just walking away.
Really?
Yeah, they're quitting their high-paying leadership roles without having another job lined up.
Just totally burnt out.
Exactly.
And when you look at the exit interviews and the underlying reasons, it is a jarring picture of the dark side of this productivity boom. These leaders are dealing with something the industry is calling founder slop.
Yes.
You have startup CEOs who are getting access to these powerful frontier models and experiencing what some engineers sarcastically call AI psychosis.
Oh, wow. The scenario goes like this. A CEO decides they want a massive new feature.
Right.
Instead of scoping it out with a team, they spend the weekend generating a 60,000-line pull request using an AI coding assistant.
Oh my God.
They force that massive, largely untested block of code into the core product. And the engineering team is then left to manage, debug, and untangle this absolute mountain of broken technical debt.
So the engineering leaders are burning out trying to manage the chaos, and they're just throwing their hands up and leaving.
Yeah.
But beyond the burnout, there is a much deeper philosophical warning here. Adi Osmani, a highly respected engineer who recently left Google, wrote about a phenomenon he terms cognitive surrender.
Yes, cognitive surrender happens when software engineers rely so heavily on AI agents to write, debug, and deploy their software that they slowly atrophy their own understanding of the systems they are building.
Right.
They no longer understand the underlying architecture. They surrender the cognitive map of the code base to the machine.
Because if you aren't struggling through the logic to build the thing, you don't actually know how the thing works.
Exactly.
So what happens when something fundamental breaks deep inside the architecture that the AI cannot easily parse or fix?
It's a huge problem.
If AI makes it so effortless to generate code that the builders themselves no longer comprehend the software, are we constructing a digital civilization that no human actually understands anymore?
It is the ultimate vulnerability. We might be gaining infinite velocity in how fast we can build, but we are risking total amnesia regarding how the engine was constructed in the first place.
Which brings us full circle to where we started.
It does.
Let's do a rapid-fire recap of the massive shifts we covered today.
Let's do it.
OpenAI hit the emergency brakes on Astra's training run to rebuild their defenses against critical cyber capabilities. Asana and ABC Legal deployed AI agents to compress years of massive engineering overhauls into literally a few weeks.
Yep.
Cursor merged into the SpaceX empire for infinite compute, while Replit integrated OpenAI models to bring software creation to the masses.
Right.
And burnt-out tech leaders are sounding the alarm on the rising threat of cognitive surrender.
It has been a week of incredible acceleration, tempered by some very necessary reality checks about control and comprehension.
Absolutely. Well, thank you all for joining us on this deep dive. If you found this episode useful and it helped clear the noise for you, please take a second to read the podcast and leave us a comment on Spotify or Apple Podcasts.
Yes, it genuinely helps the show. We appreciate you taking the time to parse through the signal with us.
And as you head into the rest of your week, I want you to think back to that rocket metaphor. If we are handing over the navigation systems, the blueprints, and the flight path to the machine itself, and we slowly forget how the engines actually work. Wait, I shouldn't say that. We slowly forget how the engines actually work, who is really flying the ship. We'll see you next week on the AI Loop.